Contour Integration Theoretical Expected Examples Assignment 2. In this assignment, I am going to solve the examples in the another way. There is another method to solve the examples which are very easier, right? Alright, the example is prove that 0 to pi cos 2 theta over 1 minus 2a cos theta plus a square d theta is equal to pi a square over 1 minus a square, where a square is strictly less than 1. You can solve this example as in the previous videos, the method I used. You can solve this example according to that method also. But today I am going to tell you a very important, a very easier method to solve such kind of problems. Now here e the power iota theta, this is the remark. We know that e the power iota theta is equal to cos theta plus iota sine theta. Therefore, if you see, the real part of e the power iota theta is cos theta and the imaginary part of e the power iota theta is sine theta. I am going to use this in this example. Now we have given the integration 0 to pi cos 2 theta over 1 minus 2a cos theta plus a square d theta. Can I write this integral as the real part of? Yes. Here nothing to do with the denominator. We just have to make changes in the numerator only, right? So in numerator I am having cos of 2 theta. Can I write it as the real part of e the power 2 iota theta? See, e the power iota theta, its real part is cos theta. Check the angle. Here it is theta, here it is theta. Now I am having 2 theta. So can I write it as real part of this integration 0 to pi e the power, yes, here angle is 2 theta. Can I write it as 2 iota theta? Yes? Are you getting? Okay. Denominator write as it is. Nothing to do with the denominator. We just have to make changes in the numerator. Now we will evaluate this integral, right? So I am having 0 to pi e the power 2 iota theta over 1 minus 2a cos theta plus a square d theta, right? Now because what I have to do is, here limit is from 0 to pi. I need my limits to be in 0 to 2 pi. So I have to divide by 2. So this integration, to make this from 0 to 2 pi, I must divide by 2. That's it. And because it is because if you check the rule that cos of 2 pi minus theta, here in this e the power 2 iota theta, this is equal to cos of 2 theta plus iota sine of 2 theta. If you check, the cos of 2 pi minus theta is obviously cos of theta, and here if you check the sine of 2 pi minus theta, this is also the same. So the rule is satisfied. Right? So we have f of 2 pi minus theta is equal to f of theta. The rule is satisfied. So we just have to change the limits. So now this is equal to 1 over 2. Yes. I have to write this. Put z equal to e the power iota theta. And then you have d theta is equal to dz over iota z. So e the power 2 iota theta is z square over 1 minus 2a by 2 z plus 1 by z plus a square, and d theta is dz over iota z. Right? If you solve the denominator, you will get the next step as this. Take whole of this, the integration, what is I am having the function in this integration, take that function as f of z dz, where your f of z is equal to minus 1 over 2a iota z square over z square minus a plus 1 over a z plus 1. Next step, we are going to find the poles. Now the poles of fz are given by taking the denominator equal to 0. And this z square minus a plus 1 by az plus 1 is equal to 0. This is your quadratic equation. If you solve this, you will get the two roots, that is z equal to a and z equal to 1 over a. Because it is given in the question that there is a condition that a square is less than 1. Now we have to check which root or which pole falls inside the circle. Because a square is less than 1, which means square root of a square is strictly less than 1, which implies, now this means mod of a is strictly less than 1, which implies 1 over mod a is greater than 1, which means 1 over a, this pole lies outside the circle because we are having the unit circle, mod z equal to 1. So 1 by mod a is greater than 1, that means it is lying outside the circle, right? So the pole at z equal to 1 over a lies outside the circle. See, so the only pole remains is z equal to a, which lies inside the circle. So now residue of fz at a is equal to limit z tends to a, z minus a into f of z. So this is equal to, I'm writing, this is limit z tends to a, z minus a, f of z. Writing the value of f of z, I'm taking this minus 1 over 2a iota outside of the limit and writing remaining rest of the terms. Z square minus a plus 1 over a z plus 1. Now leading coefficient is 1 only here. So I will write minus 1 over 2a iota limit z tends to a. Yes, this is changed into z minus a. This is nothing but I am factorizing. So these two are cancelled out. We are lefting up with this only, which is equal to put z equal to a over here. Minus 1 over 2a iota a square over a minus 1 over a. On solving this, you will get a square over 2 iota 1 minus a square. So now applying the Cauchy residue theorem, we get the given integration is equal to f of z dz, which is equal to 2 pi iota into the residue of fz of the pole which lies inside the circle. So residue we get as this. So this is a square over 2 iota 1 minus a square, which is finally equal to pi a square over 1 minus a square. Now remember this value is equal to this integration e the power 2 iota theta. We have solved for this integration, right? So this value is for this integration. Just one line you have to write, equating the real parts. That's it. And then get back to your given integral by writing this line, which means we are talking about our given integral. So the given integral is equal to, because the right hand side is already in the real part. So this given integral is equal to pi a square over 1 minus a square. Alright, next example. Prove integration 0 to 2 pi cos 2 theta over 5 plus 4 cos theta d theta is equal to pi by 6. Again, taking the same concept, this integration is equal to real part of, yes, what is the angle given over here? Again, cos of 2 theta. So this is the real part of e the power 2 iota theta. We have just make changes in the numerator, nothing to do with the denominator, only you have to make changes in the numerator. Now already limits are in 0 to 2 pi, right? Very good. No need to change the limits. So we evaluate this integral, putting z equal to e the power iota theta here and d theta as dz over iota z, you will get. So this integration will become, right? See, whenever you put the z in, whenever you put the integration in z form, you have to write c over here, which indicates about the circle. So this is equal to z squared. Yes, e to the power iota theta is z, then e to the power 2 iota theta is z square over 5 plus 4. Yes, cos theta is 1 by 2 z plus 1 over z. And d theta is dz over iota z, where circle is mod z is equal to 1, which is equal to this integral, and taking whole this as f of z dz, where f of z is 1 over iota z square over 2z square plus 5z plus 2. Now the poles of fz are given by, I am putting the denominator equal to 0, which is now your quadratic equation. Find out the roots. The roots of z is equal to minus 2 comma minus 1 by 2. Yes, which of the roots falls inside the circle? Of course, minus 1 by 2. Yes, because the circle is the unit circle. Mod z is equal to 1. So clearly, the only poles of fz inside the circle is at z equal to minus 1 by 2. You can check in the diagram. This is the circle mod z equal to 1. You will see that z equal to minus 1 by 2 falls inside the circle and minus 2 falls outside the circle. Now we have to calculate the residue for this pole z equal to minus 1 by 2. So the formula is limit z tends to minus 1 by 2, z minus 1 by 2, right? Because the formula is limit z tends to a if pole is at a, z minus a f of z. Now here a is minus 1 by 2, so it is changed to z plus 1 by 2, right? F of z. This is equal to limit z tends to minus 1 by 2, writing the value of fz here. So this is z square over iota 2z square plus 5z plus 2. Now limit z tends to minus 1 by 2, z plus 1 by 2. I am writing this in factors. Iota. The leading coefficient here is 2. So I am taking the leading coefficient outside this bracket. This is 2 and writing this because what are the roots? The roots are minus 1 by 2 and minus 2. So I am writing z plus 2 and z plus 1 by 2 and cancelling this z plus 1 by 2 with each other, and I am lefting up with 1 over 2 iota, this 1 over 2 iota taking outside the limit, and this is z square over z plus 2. Now put the value z equal to minus 1 by 2 over here and you will get your answer to be, if you solve, you get 1 over 12 iota. Right? So by Cauchy's residue theorem, the given integral, which is equal to f of z dz integral over c, this is equal to 2 pi iota times the residue of fz at z equal to minus 1 by 2, which we have calculated as 1 over 12 iota. So I am writing the value for the residue 1 over 12 iota. Iota iota cancel, so this is pi by 6. Now this is the value for this integral. I must write the line. This integral is nothing but, if you open this is cos 2 theta plus iota sine 2 theta, right? Equating the real parts on both the sides, check. Equating the real part is this. And this is of course your real part. There is no iota, right? So this integral 0 to 2 pi cos 2 theta over 5 plus 4 cos theta d theta is equal to pi by 6. This is your given integral, right? Hence the result. So this is how easier to solve such kind of examples by taking this kind of method, right? So go through these two examples. We are going to solve some more examples in the next video, and whosoever wants to enroll my course Real Analysis or Vector Calculus, that is live on Udemy, you check the description box. The coupons for the course are provided in the description box. You can go through them. Thank you guys. God bless you. Have a nice day.